All right, today we're going to be talking about the parts of an expression. Does anybody know the difference between an expression and an equation? Okay, Zaire. Right, an equation has an equal sign. Okay, an expression doesn't. So we're going to identify the terms, the coefficient, variable, exponent, and the constant of each of these expressions. Number one, all you have is a number 8. So that's just one term, and the term is 8. Okay, number 2, okay, that's what people think, but anytime it's a number and a letter mashed together like that, it means they're being multiplied, and it's still one term. And the one term is 12a. Well, we're going to get there. We're going to get there. Look at number 3. See how this time it's 7b minus 1? Okay, this time that's 2 terms. What's the first term? 7b. What's the second term? Negative 1. Okay? You have to attach the sign to it. Whatever sign before it, you attach to it. Okay, number 4, how many terms are there? And what is that one term? C to the 4th power, or C raised to the 4th power. Number 5, how many terms are there? Right. What is the first term? Okay. Second term? And third term? Negative 6. Number 6, how many terms are there? 2. What's the first one? 9e to the 3rd power, or 9e cubed? Okay, what's the second term? Negative 4. Okay, number 7, how many terms are there? 1. What is that one term? F to the 5th power. Okay, number 8, how many terms are there? And what's the first term? What's the second term? And then negative 5g. Right. Okay, number 9. What is the first, how many terms are there? 3. What's the first one? Right. What's the second term? 5h. And the third term? Right. Okay, and then number 10. How many terms are there? What's the first one? Second one? And third one? 11. Okay, in the next section, we're going to identify the parts of the expression. So like the coefficients, the variable, the exponent, and the constant. All right, number 11. You have the expression 2k minus 5. Now, a coefficient is a number that's beside the variable. It's being multiplied by the variable. So in that expression, what's the coefficient? 2. Why is this negative 5 not a coefficient? It does not have a variable. Okay? Can the 2 change? Think about it. If I plug in a 3, what will this all become? 6. So yes, the 2 can change depending on what you plug in for k. Can the negative 5 change? No, that's why we call it a constant, because isn't the definition of constant like remains the same, doesn't change? Okay, what's the variable for this expression? K. And then what's the exponent? There is a 1. Anytime you have a variable, you have an exponent, and if it's not visible, it's an understood 1. Okay, number 12, what's the coefficient? 1. Anytime you have a variable, there's an understood 1 in the coefficient spot and in the exponent spot. Okay, so the coefficient is 1. What's the variable? What's the exponent? And what's the constant? Okay, what about number 13? What's the coefficient there? Variable, exponent, and constant 6. Number 14, coefficient, variable, exponent, and constant. Okay, number 15, coefficient or coefficients. Right, there's 2 this time because you have 2 well, you have the same variable. They're both q's, but one's q squared, one's q to the first. This one's coefficient is a 12. What is this one's coefficient? 1. Now, the variable's q, and then the exponents are what? 2 and 1. And what's the constant? Negative 2. Okay, now number 16, we're going to need to simplify before we can identify each part. What part can be simplified? Right, what is 3 to the second power? So instead of writing that, just write minus 9. So now what is the coefficient? 4/5. Even though it's a fraction can still be a coefficient. It's still a number that's multiplied by a variable. What is the variable? What's the exponent? And what's the constant? Negative 9. Number 17, is there any part that needs to be simplified? No. So what's the coefficient? A negative 3 though. What's the variable? What's the exponent? And 1, because this s is to the first power. And then what's the constant? Negative 1/2. Okay, number 18. For number 18, you can simplify this, because what is that 5 supposed to do? Multiply by this. Well, what's the coefficient of that t? Negative 1. So isn't 5 times negative 1 going to make a negative 5? What's the variable? T. What's the exponent? And then what's the constant? There's nothing. It would be like plus 0. So does not exist. There's no constant. Okay, number 19. What's the coefficient or coefficients? Okay, variable, exponent, and constant, 4. And then number 20. What's the coefficient? Variable, exponent, and constant, 4. Okay, are there any questions from this page? Okay, go ahead and flip to the next one. All right, shh, pay attention. Read the algebraic expression and answer the questions that follow in the box on the right. Okay, this time the expression is 4x minus 2y plus 3. What are the 3 terms in the expression? Very good. The term is the whole thing. So, and Courtney said all parts. He said 4x, negative 2y, and 3. They're asking for the entire term. Not just the coefficient, not just the variable, but the entire term. Okay? What are the variable terms? Or a better way to ask that is, which terms have a variable? Right. 4x and negative 2y are the terms that have a variable. What is the constant term, or the term that's a constant? 3. All right, next expression, 5x squared plus x plus 7. What is the variable in this expression? What's the variable? Only the variable. X. The variable is x. In this term, the x is squared. In this term, it's to the first, but the variable is x. What is the 5 in the term 5x squared called? Coefficient. Okay, and then what is the 2 in the term 5x squared called? Exponent. Sean, you with us? All right. How could y squared be rewritten? Well, if it was y cubed, that's totally different. Y times y, because doesn't y squared mean there's two y's there? Oh, yeah, but you can't combine those, and we'll talk about y in a minute. Now, what's another way that you may see y squared written? But isn't 1y squared the exact same thing? But the 1 is understood. You don't really have to write it, but it still means the same thing as y squared. Okay, what does the term xy mean? X times y. Since they're touching and there's no operation written between them, it's multiplication, so x times y. Can you combine all the x's and all the y's in this expression? No. Let's talk about y. You need to think of the terms like having a last name. Like, isn't there an understood 1 there? And his last name is x cubed. This one's last name is y squared. This person's got a hyphenated last name. You know how some people have two last names? That's like a hyphenated last name. So do any of those terms have the same last name? No. To be able to combine terms, they have to have the exact same last name. Like 1xy and 3xy could be combined. Like if they asked you to add them, you would add them and you'd get 4xy. Okay, in the back, y'all need to pay attention. Okay, or if you had x cubed and 4x cubed, you could combine those by addition or subtraction, whatever they wanted you to do, because they have the exact same last name. But they have to be identical to be like terms and to be able to be combined. Does that make sense? Okay, now let's go to the next page. Okay, we're going to fill in these squares with some words that mean addition or subtraction or multiplication. So what are some words that you hear that mean addition? Well, equals, though, could go with any of these, right? Because equals is just like the end result. Sum is the answer to an addition problem. What else? Input is more like not necessarily addition. Add. What else? What? Plus. I have heard kids say, like, what do you think, all together? I mean, it's kind of elementary, but I don't know. I don't necessarily think you're going to see that on, like, the work here, but I have heard people say that before. Yes, India? Yeah, come over here. Okay, anything else? How about increase? Increase or increase? What about, let's see, I had add plus, what about more? If they say it's 7 more than the number, isn't that adding 7 to the number? Okay, what about subtraction? What are some words you know for subtraction? Difference, less, minus. What about subtract? We try to, well, less than, we try to stay away from that, though, because when you start saying less than, what do you think of? Right, the inequality sign. Okay, what about something you said in elementary school for subtraction? Take away. You won't see that as much anymore, but that's how you would have said it in elementary school. Okay, what about multiplication? Times, product, multiply. I've heard the word by. Okay, what about division? What do you think about per for divide? Per. Okay. Quotient, I heard quotient. That's right. That's the answer to a division problem. Divide. Okay, what about over? Like 3 over 4. You would do 3 divided by 4. What about into? Yeah, I mean, that's kind of the same as over. Like it and puts it in fraction form, but to simplify it to a decimal, you're just dividing it. Okay, equality. Equal. Good job. What else? Same. Very good. Some words that you're probably not as familiar with, but you'll see today, are the words is and result. Right. Okay, what about exponents? Power. Okay, now cubed is a word for exponents, but only for which exponent? 3. So what's the other one for 2? Squared. And then what's another word you've heard me saying here when we're saying something is raised? You'll say like raised to the whatever power. Because 2 and 3 are the only ones that have a special name. The rest of them you would just have to say raised to the 4th power or power 4. You have to actually say the number. There's not a special word. Okay, now go to page 4 and we're going to try some of these. Yeah, page 4. It's not. It gets a little tricky, but it's not hard. Okay, you need to pay attention. The product of a number and 6. Okay, the first thing you need to figure out is what operation are they talking about? What does product mean? Okay, now, for number, anytime you see the word number, we're going to use X today. Okay, so anytime you use the word number, we're going to use the variable X. But look, I'm using a dot for multiplication. That's why we use a dot for multiplication in high school, well, and probably in middle school as well, because you're starting to use X for variables and you don't want to get the two confused. Now, we're multiplying a number and 6, so a number and 6. But is that normally the way we write that? How do we write it? 6x. Okay, what about the sum? What does it mean? Adding. And what are you adding together? 7 and a number. Now, would it have been okay had I written the X first and then the 7? Yes, and let's talk about why. I'm going to do a little side lesson. Not yet. Okay, we have 4 properties that we're going to talk about. Addition, subtraction, multiplication, and division. These 2 operations fall under what we call the commutative property. And in that property, order does not matter. Think about it. Isn't 3 plus 2 going to give you the same answer as if you wrote it 2 plus 3? What will you get on either side? 5. Same thing with multiplication. It's also commutative because isn't 3 times 2 the same answer as 2 times 3? They're both what? 6. So what property is that called? Commutative. Okay, the commutative property means order doesn't matter. Now, why do these 2 operations not fall under that property? Right, like look at this. If we use the same numbers, is 3 minus 2 going to give you the same thing as 2 minus 3? No, they are not equal. This one would equal what? 1, and this one would equal -1. On this division, is 3 divided by 2 the same thing as 2 divided by 3? No, 3 divided by 2 is what? 1.5. What about 2 divided by 3? No. Y'all, they can't be negative. There's no negative sign. 0.67. Okay? So it does matter with subtraction and division. You can't do it in any order you would like because it's not commutative. It's just not commutative. Okay. Number 3, really pay attention here. Okay? 5 more, this should say than 2 times the cube of a number. Let's break it down. How do you write the cube of a number? X to the 3rd power, right? That's how you write the cube of a number. How do you do 2 times the cube of a number? Put a 2 in the front. How do you write 5 more than 2 times the number? Is it 5 plus or plus 5? Plus 5. Now let's talk about why the number always comes at the end when you have words like more or less. Don't you kind of have to know what the 5 is more than or less than? Like you're adding 5 more to something. So shouldn't that something come up front and then you add 5 more to it? So anytime you see the words, Zach, you've got to pay attention. Anytime you see words like more or less, the number will come after the fact because you've got to know what they're more or less than, and that has to come in the front. So how would you write number 4? 8 less than a number squared. Right, x squared minus 8. Okay, number 5, the quotient. What does quotient mean? Divide. But in high school, we don't really use this symbol as much. We use this. What will the numerator be? Right, 3 was listed first, so it's going to be the numerator. What's the denominator? X for the number. Is equal to, so put an equal sign, 5 less than the number. How do you write 5 less than a number? X minus 5. Remember, that word more or less means to put it after, so you'll know what it's more or less than. The square of a number is decreased by 7 is equal to negative 4. So let's just break it down into many parts. How do you write the square of a number? Right. How do you decrease it by 7? And then is equal, so equals negative 4. Negative 4. Okay, number 7, the sum of 4 and 10 times the number. So what operation is it? Addition. What comes first? Well, right, but according to this sentence, we'll just put 4 first and then 10x. Now, like Courtney was saying, you could have put 10x on the left and 4 on the right, but we'll just go in order right now. But since it's commutative property, it would have been okay. Like this. Yeah, it wouldn't be the same. That would be like 14x. And this one doesn't have an x, so it can't be combined. After this page. Okay, the quotient, we're almost done. The quotient of a number and 12 equals 2 times the number squared. Okay, what does quotient mean? Divide. What's the numerator? What came first in the sentence? X. What's the denominator? 12. You're doing the quotient, which means divide x and 12, and it's equal to 2 times the number squared. 2x squared. Y'all pay attention. The difference of 7 and a number. Could we have written x minus 7? No, because subtraction is not commutative. You cannot write it in any order you want. You got to write it in the order they gave it to you in. Number 10. 6 times a number. How do you write that? Increased by 8 plus 8 is 22. Right? The quotient of 2 in a number, 2 divided by x, is equal to the sum of a number and 5. X plus 5. 5 less than a number squared. Right? And then Jana has 2 pair of jeans. Her mom and her aunt each buy her X pair of jeans. Write an expression to represent the pair of jeans Jana has now. Well, how many did she start with? 2. And then they're buying her, so isn't she adding on to her collection? And then her mom buys her X pair, her aunt buys her X pair. So we could simplify that expression to what? 2 plus, not x squared because we're not multiplying, 2x. When you are adding, you add the coefficients. Isn't there an understood 1 on each of those x's? 1x plus 1x is 2x. The only way you would get an exponent of 2 is if you were multiplying. X times x is x squared. But when you're adding, you don't mess with the exponents. You just mess with the coefficients. Number 14, John has 6 bottles of Gatorade. He sells X bottles and then buys Y bottles more. Write an expression to represent the number of Gatorade bottles John has now. Very good. 6 is what he's starting with. He's selling X, so he's getting rid of X, and then plus Y because he's buying Y more. Okay, now your classwork / homework, if it's not finished, is page 5.